Hi, this is Ms. Moore now. We're going to continue looking at dimensional analysis and getting into a little more complicated problems, a little more wordier. And as we're doing this, just keep in mind the format and the systematic way we approach it doesn't change. So looking at this first example, it says you're throwing a pizza party for 15 people and figure each person might eat 4 slices. You call up the pizza place and learn that each pizza will cost you $14.78 and will be cut into 12 slices. So the question is, how much is it going to cost you? Right? So what you're going to do when you look at this is you need to find out, what are you starting with? What do you know for sure? You know that you're going to start out with 15 people, 15 persons. Okay. Now, you need to get rid of that person. All right, that unit. So what do you know? You know that each person will eat 4 slices. So one person is going to eat 4 slices. That's a conversion factor. Look at slices. You could write slices of pizza there if you would like. But you call it pizza place and learn that. Okay, the price, you need to get rid of the slices because you want to ultimately get to the cost, which is dollars. So that crosses out. Now you've got to get rid of slices. What do you know can get rid of slices? That there are 12 slices in each pizza, 12 slices. So we can go between slices and pizza. Each pizza is 12 slices. Get rid of that. We're interested in getting to the cost. We've got to get rid of the unit pizza. Do we know a relationship between pizza and cost? Yes, we know that each pizza costs $14.78. So one pizza is going to be $14.78. And so, in the end, do we have the cost? Yes. All of our units are crossed out? Correct. So when we take this and we multiply 15 times 4 times 14.78 equals, divided by 12, you get in your calculator 73.9, but since this is money, we know it's 73.90. $73.90. Of course, that excludes taxes and delivery. That would be another problem. Example 2, you have a 57-meter fence that needs to be built. Okay? That's the given. The builder uses 35 nails for every meter of the fence, assuming there are 45 nails in a box. How many boxes? So we need to get to boxes, and in this case, we're given some conversion factors, and sometimes the conversion factors are very easy to see, and sometimes you have to read a little bit to get to them. So we're going to start, just like in our other problems, by writing down our given. I would say the given is 57 meters. And just incidentally, it really, wherever you start, as long as you can get your units to cross out, that's acceptable. I always try to find a given. So 57 meters. And we need to get rid of meters. So what we know here, that every meter, want to get rid of it, it goes on bottom, is related to 35 nails. So we'll write this. There are 35 nails in 1 meter. I just got rid of my meters. Now I have nails, but we want to get to boxes. So we do need to cross out those nails. So since it's on top, we'll put it on bottom. And do we know a relationship between nails and boxes? Yes, we do. We know that in a box, which is 1 box, there are 45 nails. So now we're in boxes, and that's what we want. So we know we can hit our equal sign. And we're going to multiply 57 times 35 times 1, and then we're going to divide that by 45. And what I got in the calculator was 44.3333. But we need to think here. We need to also use some common sense, some logic. When you go to the store, you're not going to be able to buy 44.3333 boxes of nails. And if you only bought 44, you're going to be short this many nails. What you're going to have to do is you're going to have to buy 45 boxes to ensure that you have enough nails to build that 57-meter fence. Will you have leftover nails? Yes, you will. How many seconds are in a day? All right, a day. So we're going to start out with 1 day here. And I'm going to switch to this just so you see. And we need to go between day and seconds. So we want day to cross out, so we put it on bottom. Now, you may not know how many days or how many seconds there are in a day, but you do know how many hours are in a day. In 1 day, there are 24 hours. So we just got rid of day. We're left with hours, but we want seconds, so we know to keep on. We want to get rid of hours. It's on top, so we need to put it on bottom. Now, you may know that there's 3,600 seconds in 1 hour. You may not, so let's just pretend like, hey, I don't know that. So we're going to go to minutes. 1 hour is 60 minutes, so we just got rid of the hours. If we stopped here, our answer would be in minutes, but we want seconds. So we do times again. We want to get rid of minutes. It's on top, so we put it on bottom. We're going to go to seconds. And 1 minute equals 60 seconds. So you cross that out. Then you're going to multiply 1 times 24 times 60 times 60. Get that answer, and it's about 86,400 divided by 1. And so this is what you get, 86,400 seconds. And it's in a day, exactly a day. This is exactly how many seconds are in a day. Complex units. So we've done simple one-step dimensional analysis, we've done multi-step dimensional analysis, and we've looked at doing word problems with dimensional analysis. But what about these complex units? We have a unit on top and bottom, okay? So for density would be a complex unit, meters per second, in this case miles per gallon, so we will work that. So we're going to start by writing down our given, which is 15 miles per gallon. Now when you say per gallon, it is in 1 gallon, all right? I'm going to do it with the brackets. I don't know why I started to spell miles and then I did not. Do brackets. Now you need to get rid of miles and you need to get rid of gallons because we want to be in kilometers and liters. So it doesn't really matter which one you start with. I'm going to start getting rid of my top unit. This would be one of those cases we don't expect you to know necessarily the conversion between the metric system and the English system. So here, this kind of information would be provided for you. So I want to get rid of miles. It's on top, so I'm going to put it on bottom. And we want to get to kilometers, so come over here and see if we find a relationship between miles and kilometers, and it's right there. That 1 mile equals 1.609 kilometers. Now when we cross that out, we end up with kilometers. If we stopped here, our answer would be kilometers per gallon, but we want it to be kilometers per liter. So now we need to focus on getting rid of that gallon. So draw brackets again. Since the unit we want to get rid of is on bottom, we need to put it on top. And we need to see, do we know a relationship between gallon and volume? And so we come over here and we're going to look for gallon and, what was it, gallon in liters? Looks like right there. That 1 gallon is 3.785 liters. That crosses out. So now when we solve this, our answer is going to be in kilometers per liters, which is what we want. So we multiply 15 times 1.609 divided by 3.785. And your calculator, you get 6.37649. But this has 2 significant digits, so we'll look at that and say it's 6.4 kilometers per liter. Paying attention to your significant digits as well. A complex unit is one that has both a numerator and denominator. Okay, so we'll start with converting 65. The key here that students mess up on is they try to put that miles per hour all on top. You don't. That little slash is like writing it like this, and you need to do it like that. And when you put that hour there, remember it's not 0 hours, it's 1 hour. Okay, and I'll do this. So if we want to, I'll start this one by getting rid of the bottom unit first. Okay, so we want to go between hours and seconds. So when we look at this, we can say, okay, 1 hour. We want to go from hours to seconds. We can go from hour to minutes. 1 hour equals 60 minutes. Gets rid of that. If we stopped here, our answer would be in miles per minute, but we want to get to seconds, so we'll do it again. We want to get rid of that bottom unit. And 1 minute equals 60 seconds. If we stopped here, our answer would be in miles per second, but we want it in meters. So let's see if we have our little thing here. All right, so what's the relationship between miles and meters? Let's see. I don't see miles and meters, but I do see miles and kilometers. So what we can do is get to miles to kilometers. So I'm going to go through this, okay? So the unit's on top, so we won't put it on bottom. So we'll go between miles and kilometers. Well, so when we do that, now if we stopped here, our answer would be kilometers per second, but we want meters per second. So then, oh, I was going to do a little bracket thing, but I'm doing the multi. Give me just a second to fix that. So now we can go from kilometers to meters, and 1 kilometer equals 1,000 meters. Now, if we stopped here, answer would be in meters per second, which is what we want. Yay! So then what we're going to do is we're going to come across and multiply 65 times 1.609 times 1,000 divided by 60 divided by 60. And then when you do that in the calculator, you get 29.0514, but this has 2 significant digits, 1, 2. And then looking at that, it's going to say it's 29 meters per second. You see, the dimensional analysis can get quite long. Here's another one. 0.78 gallons per 1 milliliter. Right, we'll just go ahead and work this one out. And we'll come over here and look at that grams. Over here, we have grams to pounds right here. So we'll go grams to pounds. 453.6 grams, 1 pound. Let's rid of that. And then we need to get to gallon. So we come over here and we see gallon to liters. Okay, so if we can get to liters, and we can do that, we know that milliliters will get to liters. 1 liter equals 1,000 milliliters. Cross that out. And now we can go from liters to gallon. And 1 gallon equals 3.785 liters. So if we stopped here, pounds per gallon, which is what we want, and we get 6.5086 in the calculator. We need 2 sig figs, so 6.5 pounds per gallon. So sometimes you're using given charts. Sometimes you have to remember things in your head as well. You can also use dimensional analysis working with density. Remember, it relates an object's mass and its volume. All right, so still same thing where start where you're given, use your density as a conversion factor. So this is a conversion factor because it's relating 1.17 grams to a centimeter, in a centimeter, excuse me. Well, it's per centimeter. All right, so how many liters? You start with that mass, 3.75 kilograms. Now this is in grams, so before we can use this conversion factor, we need to get to grams. So kilograms to grams, 1 kilogram equals 1,000 grams. Okay. So now we're in grams. So now we can use this conversion factor, grams per cubic centimeter, and it is 1.17 grams in 1 cubic centimeter. Right, so now your grams is gone. But if we stopped here, our answer would be in cubic centimeters, but we want liters. So we come over here, we do know, told you a few times, that 1 cubic centimeter is 1 milliliter. And so now we can go, say 1 liter equals 1,000 milliliters. So now we're in liters, so when we go to do that, we get, let's see, 3.20513 liters, and then with those 3 sig figs would be 3.21 liters. So you can do a lot with dimensional analysis. It's a very important skill. This concludes video 2. Make sure you've taken good notes. Come to class with any questions. You may want to rewatch the video, rewatch some of those example problems. We look forward to seeing you in class tomorrow.